And somebody tell me, what was the last problem we went over, please?
It was taking the derivative of x squared plus 4 quantity squared 2x dx, and the intervals were 0 and 2.
X squared what?
Plus 4 quantity squared 2x
There it is.
dx.
And let me see how many. I think that's it. Yep, I think that's the last one. Okay, now my my intentions today is to work over a few more problems, start 6.1, and then that'll leave tomorrow for homework questions. Okay, because I know we got some homework questions to go over, and I want to go over those tomorrow. And the reason I want to cover 6.1 today is because some people have made it through 5.5. Not everybody, but some people have. And I want to be able, I want people to be able to move forward. And then we can use tomorrow's time to go over homework questions. Hold on just a second. All right, so here is the question we were starting. I don't know how far we got. From 0 to 2 of x squared plus 4 quantity squared.
Mr. McClure, I think we finished that one yesterday.
Did we finish it?
Is the answer 8/3 over 3 minus?
Yeah, we did finish it. Okay. All right. Well, these are the questions I'm going to go over today.
Okay.
Here's one I don't think we've been over. I'm getting a little bit mixed up between the two classes. I'm getting very mixed up. So y'all have to excuse me. Where is those problems? I have some problems I meant to do for today. Just hold on. Did I do 2x dx over 1 plus x squared to the third power? Somebody tell me if I did that one for y'all.
Say the problem again.
2x over 1 plus x squared to the third power. I think I did.
I don't see it in the notes.
Yeah, I don't see it in mine either.
Okay, well, we'll do that one. The reason I did that one is because it's a fraction, and some people freak out because it's a fraction. So, all right, let's do that one. So, antiderivative from 1 to 2 of 2x dx over 1 plus x squared to the third power, and u is going to be equal to 1 plus x squared, and du is going to be 2x dx. Since we have 2x dx, that's going to be du over u to the third power. So I can rewrite from 1 to 2 du over u to the third power and bring up the u to the third power. And that will give me antiderivative from 1 to 2 of u to the negative third du. Okay? And that's going to give me from 1 to 2 u to the negative 2 over negative 2. Oh, I just took the derivative, I'm sorry, which would be evaluated at 2 and 1. Now, at this point, you can ask yourself, which way do you want to go? Do you want to change the parameters to u, or do you want to back substitute and use the original parameters? I don't really care. I'm going to go up here and I'm going to put 1, option 1. Back substitute for u and plug and chug original limits. Okay, so if you want to do option 1, you rewrite this in a nice way and bring in 1 plus x squared and use 2 and 1. That's option 1. Option 2 is to convert lower limit and upper limit to u and plug and chug. I don't really care which one you pick, but I want you to be aware of both of them. Okay, so I'm going to go over to the next page, and I'm going to do both of them. I'm going to clean this up. That's going to be what? Negative 1 over 2u to the second, evaluated at 1 and 2. So I'm going to put that on top of the page over here. Negative 1 over 2u to the second, evaluated at 1 and 2. And I'm just going to draw a line over here. Over here, I'm going to put negative 1 over 2 parentheses squared, evaluated at 1 and 2. And you're going to plug in 1 plus x squared. Over here, I'm going to put negative 1 over 2u squared, evaluated. Well, if I plug in 1, I'm going to get 1 plus 1. 1 plus 1 is 2. And 2 squared is what? I'm sorry. Not 2 squared. 1 plus 1 is 2. Plug in 2. 2 squared is 4 plus 1 is what? 5. So I can either back substitute and use the original numbers, or I can use u and convert the 2 original numbers to u numbers. So what I'm going to do is I'm going to take a yellow highlighter, and I can use 2 and 1 as long as I back substitute, or I can use 5 and 2 and not back substitute, just use u. Again, it's a personal preference. I really don't care which one you pick. -1 over 2 times 1 plus parentheses squared minus -1 over 2 times 1 plus parentheses squared. And we all know that this big line represents subtraction. And we know that the top guy is 2, so he goes right here. And the bottom guy is pink, and he goes right here. Over here, -1 over 2 parentheses squared minus -1 over 2 parentheses squared. Again, the big line represents subtraction. And this number goes here. And this number goes here. And now you just do basic math. -1 over 2 times 1 plus 4 is 5 squared is 25. Plus 1 over 2 times 4 is 8. And that's going to give you -1 over 50. And you can do that on your calculator or whatever. Let's see if we get the same thing over here. -1 over 2 times 25. Looks good so far. Plus 1 over 2 times 8. -1 over 50 plus 1/8. Looks like they give you the same thing, don't it? So why would you choose one over the other? Somebody tell me why you choose one over the other.
Personal preference.
Whichever one you want to do. But at least you're aware of both of them. And you don't go into second semester calculus going, where did the 2 and the 5 come from? Good? Feel good? Yeah, Hubert, I feel good. Thank you. You're welcome. There was a problem that I wanted to go back and show you and see if you could do it, because it's kind of like changing gears, and I'm trying to find it, and I'm not having, that might be it right there. Yeah, this is it. I don't know, we may have done it, but I'm just going to change it. I'm going to change it. So that way I know we haven't done it, because I'm making it up right now. Antiderivative from 0 to 5 of x squared plus 7 dx. And there's a reason I'm doing this one. So just do it and chill out. Excuse me. Give you a minute to work on that. Stand by. I'm going to mute my microphone. Okay. Now, why did I go to this one? Because we've been doing substitution, and I want you to be able to see if you can switch gears. Can you switch gears? How you do this one? Do you do power rule or do you do substitution?
X to the third over 3.
Do you do power rule? That's right. How do you know? Well, take u. U is equal to x squared plus 7. du is 2x dx. You can't multiply this thing by 2x. You can multiply by 2, you can multiply by 1/2, but you can't multiply by 2x. So therefore, you know it's a power rule problem. So x to the third over 3 plus 7x evaluated at 0 and 5. And now you just plug and chug. Parentheses cubed over 3 plus 7 times parentheses minus parentheses cubed divided by 3 plus 7 times parentheses. And we all know the evaluation bar gives us that. This guy is going to go here. Y'all going to miss my colors, aren't you? Well, don't worry. Guess what? The rest of the class that you're going to is going to be just as boring as no colors. So you're going to say, God, I wish I was back in Hubert's class, being weaned on a pickle and not talking. All right. What happens to the 0?
Goes out.
Zero, Hubert. That's right, class. So that leaves you with 5 to the third power. What's 5 to the third power? 125. Somebody check my math, or is it?
Yes.
Yeah, 125 over 3 plus 35 over 1, which is equal to, excuse me, 125 over 3 plus 105, check my math, please, over 3. 3 times 35 is 105, isn't it?
Yes.
220, 230. Square units. Now, why did I go back? Why did I go back to 5.3 or 5.2? Why did I do that? Well, you're going to have to be able to switch gears. You're going to have to be able to go from first gear to second gear and go from second gear to first gear. You're going to have to know the difference between the two types of integration. Capiche? Okay. Thanks for the communication. All right, now 6.1. 6.1, you're going to be finding the area between two curves. There's an example right there. Going to be finding that area right there, that red area. And this is very nice, you know, to be able to do it like this. But how do you do it by hand? So write down the blue, and I would write it in blue if I was you. If you got some crayons, you know, the only thing I have is a former Marine is crayons. So I use crayons, and you can use, you know, a different color. Some of y'all don't know any idea what the crayons means. That Marines are a bunch of dummies. That's what it means. Anyway, and write that in brown. I'm going to use brown. Okay. what are you supposed to do when you're given a problem like this and it says find the area between two curves? What are you supposed to do? Well, we're going to go to our handy dandy whiteboard. Number one, I want to write in red, but my red marker's out. And I go to Walgreens and I keep forgetting to get them. Okay, number one, graph / sketch. Now, while I suggest using your graphing calculator on the test, I suggest you sketch on your homework so you can see it better. Because the calculator is so small, it's better when you sketch it. Number two, find intersections. Now, for the homework, I suggest you do it by hand. For the test, I suggest you use your calculator. 3, set up parameters / limits, your lower limit and your upper limit. And 4, the area between two curves is the antiderivative of f of x minus g of x. That's how you find the area between two curves. Now, let's take our two curves that we've gotten. I'm going to give everybody a second or two more to copy that down. And I went ahead and sketched the two curves. There's the two curves. Now, if you haven't sketched them yet, I want you to draw this in your notes because it's very important that you see it up large so you can see what you're actually doing. That's why you need to sketch these things. And you see, as well as here, that you have to have an intersection point on the left and you have to have an intersection point on the right. Can anybody tell me, and I'm expecting at least 1 or 2 people to know, how to find the intersection points without using a calculator? You have to unmute your mics.
Set the
Just look
function
on the graph.
What, Mr. Paris? Go ahead. I thought, what?
Set the functions equal to each other.
Write that down. Set the functions equal to each other. Okay, so I'm going to have to set functions equal to each other to find these 2 points. Set functions equal to each other. And that's how you find your intersection points. Is that one of those things that you need to remember? Oh, hail to the yes. Because this is where second semester calculus starts. After the review, after you've had a day of review, this is where it starts. So you better remember that. So here we go. We're going to set those equal to each other. Let me get my blue pen. Where'd my blue pen go? All right. So x, negative x plus 5 is equal to the brown. I guess I'll have to go with bronze. X minus 1.
I think the blue should be negative x squared.
Thank you. So I'm going to bring these two over. So that's going to be negative x squared minus x plus 1 plus 5 is equal to 0. Negative x squared minus x plus 6 is equal to 0. I'm going to use complete the square. Negative x squared minus x plus blank is equal to negative 6 plus blank. Factor out a negative 1. Half of 1 is 1/2. 1/2 squared is 1/4. Negative 1, shortcut number 1, x plus 1/2 quantity squared is equal to negative 6. That'd be negative 25/4. Divide by negative 1. X plus 1/2 quantity squared is equal to 25/4. X plus 1/2 is equal to positive or negative 5/4 or 2. X is equal to positive or negative 5/2 plus 1. What is 6/2?
3.
And what is negative 4/2?
Negative 2.
So there is our two x-intercepts. I'm sorry, not our x-intercepts. That's where they thought it was supposed to be negative 3.
Where you added that 4th, where you added that 1/4.
Yeah, it's supposed to be a minus 1/2.
Fine.
Minus 1/2. Be a negative 3 and a positive. There we go. I knew there was a mistake in there somewhere. So this point right here is at negative 3, and this point right here is at positive 2. So now your parameters right here are going from negative 3 to positive 2. I'm just letting y'all look at that again because that's where the region that we are finding, that's where it starts and that's where it ends. Now, if you were not from America and you were from the Middle East, then you do it this way. Because you're used to going which way? Well, it's supposed to move right. Whatever. It's not working. It's supposed to, wait a minute, let me reset it. Where is my, let me open. Sometimes this thing hangs up. Now let me do it. There we go. You can do it from right to left, or you can do it from left to right. Doesn't matter. It depends on if you do it from left to right, then you put the lower number and you don't have to worry too much about the negatives. But if you do it from right to left, you'll be taking negative 3 minus 2 and that might mess some things up. Okay. So now we're going to set up our, based on this. Now, somebody tell me, which one am I going to subtract from, which function am I going to subtract? In this case, f of x minus g of x, that's pretty simple. But how do you tell when you don't know which one's g of x and which one's f of x? You go with which one gives you the highest y value in your region. Where is our region? Our region is right here. Everybody got that? So I want you, let's see, Mr. Michelle, pick an x in the yellow region. Pick an x.
-2.
Okay. Plug in -2 right here. Well, -2 squared is +4, but it's got a negative. -2 is going to give you a +1. So -2 gives us a +1. What does -2 give you over here? -2 minus 1. -2 gives you a -3 over here. So which one gives you the higher y value? F of x or g of x?
F of x.
F of x.
So I call it dominant, okay? Now some of y'all might think that's offensive. I don't know. I don't know what you want to call it, okay? I don't really care, all right? I'm calling it dominant because it gives you the higher value in your region for what? For y. If you want to call it stronger, if you want to call it fancier, if you want to, whatever ER words you want to use, I'm calling it dominant because it gives you the higher value of the region. So that one is what I'm going to subtract from. And you will see problems in the future. And this one is right here, see? It's above the x-axis. It's dominant. And you'll see in the next problem, the next example, you'll see what I'm talking about. So I'm going to set up my equation now. And it's going to be the antiderivative from -3 to 2 of -x² plus 5 minus x minus 1. All right, do the algebra and do the antiderivative and plug and chug and do the mathematics. Give you a minute or two. Give you 2 minutes. Okay, so -3 to 2 of negative x squared plus 5 minus x plus 1 dx. -3 to 2 of negative x squared minus x plus 6 dx. And that's going to be negative x cubed over 3 minus x squared over 2 plus 6x evaluated at -3 and 2. So I'm going to go to the next page and we're going to do the math. So negative, and you can put parentheses to the third over 3 minus parentheses squared over 2 plus 6 times parentheses minus parentheses cubed over 3 minus parentheses squared over 2 plus 6 times parentheses. And we're going to plug in a 2 here, a 2 here, a 2 here, a -3 here, a -3 here, and a -3 here. And I'm going to get -8/3 minus 4/2 plus 12 over 1 minus 27/3 minus 9/2 minus 18 over 1. Now the reason I'm making everything a fraction is because I'm going to get a common denominator because I'm not going to depend on the calculator to do my math. Okay? So, and when you do that, you're going to get, let's see, this will be negative, we got a 6 is your common denominator. So that's going to be -16 over 6 minus 12 over 6. 72 over 6. 54 over 6 minus 27 over 6. And 108 over 6. And that trickles down to 125 over 6. Somebody do that on the calculator. What does that come out to be? What's 125 over 6?
20.8.
20 point what?
20.8.
20.83, I believe.
Yes.
Let's see what the calculator says. I meant the, look at there. See if I can stop it. See if I can stop it right there. Oh my gosh, look at there. 20.83. That's what you're supposed to be doing. That right there, what's on the screen, that and this is what you should be able to do. You'd be surprised on how many people sit through Calculus 2 and you ask them what they learn. I mean, Calc 1, and they, I don't know. I know about an antiderivative and a derivative. They don't know what they just done. They're just found the area under the curve or between the curves. Don't you feel good about yourself? Let's try nerd. Oh yeah, that'll make y'all quit. I'll put that one on the test. Go ahead and draw it out. You got a blue one and a brown one. And that's the area you're finding right there in the red. And go ahead and see if you can set them equal to each other. See if you can find the 3 intersection points and set up your antiderivative. There's 2 of them. You're going to have 2. You're going to add them together. The little area plus the big area. And if you can't do it, then we'll all assume what? You know, just don't want to face it, do you? It's okay. We'll face it together. We all consider you a failure. I don't think y'all would laugh at a Chris Rock concert. Boy, y'all are weaned on a lemon and a pickle. Miss Seiler, you're not that confused, are you? You got that disgusted, I'm confused look. Mr. Mulder, he just, I can't quite figure out what that look is, Mr. Mulder. I'm trying to look at y'all's faces and it's just nothing. Miss Parker's making me dadgum dizzy. Dadgum, she's chowing down on something. She's angry. That's when you're hungry and angry at the same time. Oh, Lord. Well, I already sketched it. There's my sketch, which doesn't look as good as theirs, but there it is. So I'm going to take these 2 and set them equal to each other. Negative x squared plus 2x plus 5 is equal to x cubed minus 3x squared minus x plus 5. And I got to get everything, since x cubed is positive, I'm going to bring everything over here. So 0 is equal to x cubed minus 3x squared plus x squared minus x minus 2x plus 5 minus 5. And y'all see the 5s do what? They cancel. 0 is equal to x cubed minus 2x squared minus 3x. Y'all help me out. Does that look good? Factor out of x. X squared minus 2x minus 3. 0 is equal to x, and 0 is equal to x squared minus 2x minus 3. Use reverse FOIL. No, I do not pronounce it. 1 and 3, negative and positive. So x is equal to 0. -1, and +3. And there's your 0. And there's your -1. And there's your +3. So our regions are going to be from -1 to 0 to get the pink region, and from 0 to 3 to get the yellow region. What are y'all going to do next semester when y'all don't have my colors?
Perish.
Oh, you know, we'll just quit.
There you go, just quit. No, what you ought to say is, Mr. and Miss So-and-so, would you use colors like Hubert did? Oh, God, that would go over really well. Now, when you set up, what's the dominant on the pink? Somebody tell me, what's the dominant function on the pink? Brown or blue?
G of X.
Brown, yes. Because if I pick like 0.5 right here, 0.5 is going to give me a higher number with the brown. So G of X minus F of X on the pink region. And what's dominant on the yellow region? F of X. So there is your setup for, write it down. And I want you to start doing the algebra. Go ahead and start. What are you doing?
Hubert, would you mind explaining again how you got that order for the equation? I'm just still a little confused.
Look at the graph. Which one is dominant right here? See, in other words, dominant. When I plug in x is equal, let's plug in, this is -1. How about 0.5? When I plug in 0.5, I get a number here, and I get a number here. Which one's higher, the blue or the brown?
The brown.
So from the pink region, the brown is the dominant.
Okay, I see that.
Okay, let's pick 0.5 right here. There's your point, and there's your point. Which one's dominant, blue or brown?
Blue.
And that's the one that's dominant. So when you set up your function, here's your dominant, and here's your dominant.
Okay. Okay, that makes sense. Thank you.
Let me ask you this, Mr. Michelle, what would you rather do? 7 minus 3 or 3 minus 7?
7 minus 3.
Okay. 7 minus 3, 7 minus 3. You always want the bigger number. You always want to subtract from the bigger number. In this case, you're subtracting from the more dominant function. And on the pink region, the more dominant function is the brown function. Here on the yellow region, the more dominant function is the blue. So that's why I set it up like this.
Okay, that makes sense. Thank you.
Mm-hmm. I'm glad you got sick of that stuff. All right. So where's my... All right, so let's go ahead and do this algebra right here. I'm going to write from -1 to 0, x cubed minus 3x squared minus x plus 5 minus, there'll be plus x squared minus 2x minus 5. Y'all check me on that. And then the next one, plus 0 to 3, and that's going to be -x squared plus 2x plus 5 minus x cubed plus 3x squared plus x minus 5. All right, y'all check me and make sure I didn't make a mistake. All I did was put these two together with the minus symbol distributed. And I'm going to take my, let's see, I know we can combine 3x squared with that x squared, and this 2x with this -2x. And the 5's cancel. There's some chips over there. Okay, and that's going to be -1 to 0, x cubed, -3x squared, that's -2x squared, -3x dx. And then this one, from 0 to 3, let's see, -x squared and 3x squared. So -x cubed, and 3x squared minus x squared is 2x squared. Two x plus x is 3x, and the 5's cancel. So now I'm going to write these two and add them together because you're still adding them.
Is it just a coincidence that on these two functions, the
Just the sign, yeah. The sign will always be the opposite. Yes. Is that what you were asking? Mr. Parrish froze up on us.
I guess it's that they're exactly just inverted, just the signs are swapped, but they're the same function.
Okay, now you brought up an interesting point. What if you didn't do the dominant minus the non-dominant or submissive? Okay, what if you didn't do this? Then you would have to, you would get a negative area, which you would have to say in your mind, there is no such thing as a negative area. And you would have to ignore the negative, and you'd still get the right answer, but you got to ignore the what? The negative. Everybody with me? So, all right. So here's what we got. We've got the interval from -1 to 0 of x cubed minus 2x squared minus 3x dx plus from 0 to 3 -x cubed plus 2x squared plus 3x dx. And this is the pink area. And this is the yellow area. Excuse me. All right, find the antiderivative. X to the fourth over 4 minus 2x cubed over 3 minus 3x squared over 2 evaluated at -1 and 0 plus negative x to the fourth over 4 plus 2x to the third over 3 plus 3x squared over 2 evaluated at 0 and 3. So 0, because 0 is going to make everything go out, minus parentheses to the fourth over 4 minus 2 parentheses to the third over 3 minus 3 parentheses squared over 2. Somebody tell me, why did I put that 0 here? I've never done that before. Why did I do it here?
Because we know the 0 is going to cancel everything out.
No, I've done that before, but I didn't put the 0 down here. Anybody? That's a good guess, but this is the first time you've seen me put 0 right here. Why did I do that?
To keep the
Because
negative.
0 is greater than.
Keep going, Mr. Paris. What?
To keep the negative, because you're subtracting from 0.
Right here. This negative, will it cause you trouble? Yes. If you don't acknowledge this negative right here, you're going to get the wrong answer here as far as a negative and a positive. You've got to keep that negative in perspective. When you subtract 0, does it matter? No. That's why I haven't been putting this right here. But here, we're not subtracting 0 from a number. We're subtracting a number from what? 0, and it makes a difference. Does everybody understand that? Okay, that's why I put the 0 right here, because of that negative. All right, now I'm going to plug in my green number. I meant my red number. -1, -1, -1. And that's going to give me 1/4. Let's see, that's a -1, makes that a -2, positive 2/3. Y'all check me, please. -1 times -1 is positive minus 3/2. Now over here, negative parentheses to the fourth over 4 plus 2 times parentheses cubed over 3 plus 3 times parentheses squared over 2 minus 0. And I really don't need this because I'm subtracting 0, so I don't really care about that. This one is important. This one is not. So I'm going to put a 3 here, a 3 here, and a 3 here. And that's going to give me, oh gosh, 81. Somebody check me. I believe that's 81. So that's negative. That'd be a 81. That's a negative 81 over 4. 3 squared is 27. That's 54 over 3. 9 times 3 is 27 over 2. Y'all check me, please. Got to get a common denominator. I would say 12. So 4 will go into 12. 3 times 1 is 3. 3 will go into 12. 4 times 2 is 8. 2 will go into 12. 6 times 3 is 18. 4 will go into 12. 3 times 81 is 243. Please check me. 3 will go into 12. 4 times 54 is 216. Somebody check me. 2 will go into 12. 6 times 27 is 144. I hope. I don't know. Somebody check me.
$27 and 6 is 162.
It's what?
162.
Thank you. So 3 plus 11 minus 18, I believe, is -7, but that's going to be positive. So that's going to be 7 over 12 plus -243 plus 216 plus 162. Somebody give me that. What's -243 plus 216 plus 162? What is that?
135.
I got 135.
And 135 plus 7 is what? 142?
Yes.
Somebody, what is 142 divided by 12? Give me a number. What?
I was just reducing it.
What's 142 divided by 12?
11.83.
11 point what?
83.
Square units. Let's see. Well, I missed that one. Sorry. Dadgummit. Try one more time. It's not letting me. Let me do this slow. Why isn't it putting the number? And you have to add. It says they don't have the answer. Why doesn't it have the answer? It's not giving us the square footage or square whatever. Well, I don't know why it's not giving us the answer. There it goes. Right here. Why is it doing undefined? It's not undefined. I don't know why it's doing that.
Could you do it
Unless,
separately and
what?
do could you do it separately and do the first part and then add it to the second little part? Do you think that would work? Or is it-
You're supposed to add them, yes. What'd you ask? I'm sorry.
Never mind.
I don't know why this is saying undefined square units.
If it'll give you the first little part and you could stop there and then take the rest of it second and add them together, I wonder if it would still say undefined.
I don't know. Let me. I can't. That right there is. I can't back it up. Let me see if I can back it up. Nope. Okay, 0.581. Somebody tell me what 7 divided by 12 is.
583.
Okay. We got that right. We got it right. I just don't understand. One integral.
You you've
They're saying that
got to
this
change.
is
It's
over.
going. It's trying to do.
I'm sorry, what?
It's still trying to do the integral from -1 to 3. What if you changed it from 0 to 3? Can you adjust that to left bound?
I can't change it. Let me do little 0. Well, I'll be dang. Thank you, Mr. Paris. You're a pretty good fella, no matter what Mr. Michelle said. Hold on a second. Let's see if I can turn it off right here. All right, somebody take 11.25 or somebody take, what is 135 divided by 12?
$11.25.
There you go. Don't y'all feel like y'all smart now? Oh, well, I guess not.
Yes, Hubert, we did.
There you go. You don't feel like a failure living in a van down by the river, do you? Okay. That's enough for today. That's enough brainwashing for today. Let me check the roll right quick.
I've got a quick question. You mentioned homework for chapter 6. Mine stops at 5.5.
Yeah, I gotta assign it. Y'all gotta let me assign it. Can I be in charge for a while? Dadgum, y'all rough. Dadgum hurrying me up.
Hey,
You're staying on the ball, Mr.
no,
Paris.
I haven't even got there yet. I just want to.
Mr. Paris, I'll just turn it off. How about that? All right.
Does that mean I don't do it?
Yeah, you still got to do it. You got to find it. I'm going to hide it and you can find it. Attendance tracker. Let me turn the recording and everything off.